Hello, this is section 5 of chapter 6, the remainder and factor theorems. Today we are going to divide polynomials and relate the result to the remainder theorem and the factor theorem. So if you have some function f, let's say right here we have a function that we call f, and we're going to divide it by another function called d. So we take f of x divided by d of x. The result is going to be some quotient q of x, but then we're going to have this left over, and it's what we call the remainder. All right, now if you think back to when you first learned long division and first learned about division, you had this concept of a remainder. And it's basically what's left over. This q is how many times d goes into f evenly, and then the r is what's left. Well, we can write remainders as fractions as just r over our divisor d. So any function f divided by function d is going to yield a quotient function q plus the fraction of our remainder over our divisor d. Okay, and we have two different ways that we're going to divide today. First one is long division, second one is synthetic division. Okay, this kind of ties into the synthetic substitution that we saw a few sections ago. Okay, first, long division. We're going to go back to when you first learned how to divide and actually carry out long division. So if we want to take 2x to the fourth plus 3x cubed plus 5x minus 1, and we want to divide by this quantity, we're going to use long division. Now, here's one little thing that we need to do here. We need to take this piece right here, and we need to, here, let me fix that. We need to erase this, and we need to add in a 0x squared. Now, why do we need to add that in? Well, we have to have a placeholder. We can't just go from x to the fourth and then x to the third all the way down to x. We need to have that 0x squared in there. All right, and it'll make sense once we get into the division here. So if we want to use long division here, and we're dividing by x squared minus 2x plus 2. Okay, when we do this, we solely just look at the first term here. We're only looking at this x squared. We're really not worried about the minus 2x and plus 2. We're only going to look at the x squared. Those other two are just going to hang along for the ride. So we ask ourselves, if we take 2x to the fourth and divide by x squared, what do we get? Well, that gives us 2x squared. Okay, so this divided by that is 2x squared. Well, our next step, if you remember back to long division, we take whatever this number is and we multiply, so we get 2x to the fourth, but we have to multiply that to each term. So this becomes minus 4x cubed plus 4x squared. Okay, and then we can subtract. Remember, we want to subtract that from what we have there. Okay, we subtract those, they go away. We subtract this, we get a 7x cubed. Remember, 3 minus a negative 4 is 7. And then we subtract here, we get minus 4x squared. Okay, and then we'll go ahead and drop down the plus 5x. Okay, so once again we ask ourselves, well, what do we have to multiply x squared by to get 7x cubed? Or if we take 7x cubed divided by x squared, what do we get? Well, that is a positive 7x, because 7x times x squared is 7x cubed. And then once we have that, we just continue and multiply by these other two terms. So this gives us a negative 14x squared, and this gives us a positive 14x. Okay, once again, we want to subtract this polynomial. So if we subtract, those cancel out. If we subtract, we get a 10x squared. And if we subtract here, we get a negative 9x. And we drop down the negative 1. That negative 1 comes all the way down. So we ask ourselves, what do we have to multiply x squared by to get 10x squared? Well, that is a 10. So multiply that through, get a minus 20x plus 20, subtract, make sure we remember to subtract. Those cancel out. We get 11x minus 21. And that is our remainder. So we can write a plus 11x minus 21 all over our divisor, which is x squared minus 2x plus 2. Okay, now I threw a lot at you right there. So go ahead, take a second, look it over, possibly even rewind the video, go back through, and make sure that you understand where all this is coming from. Once again, where did we get each of those? Well, these are just taking our leading term and dividing by x squared. We ignore the rest of those, just x squared, to get these numbers. And then we multiply through to get what's left. Okay, what that leads into is our remainder theorem. And our remainder theorem says that if a polynomial f of x is divided by this binomial here, x minus k, then the remainder, r, is equal to f of k. So basically, if we divide by a binomial x minus k, the remainder is just going to be that function evaluated at k. So some examples, if we took f of x and we divided by x minus 2, well, the remainder, whatever would be left over, would just be f of 2. And likewise, if we took g of x and divided by x plus 3, well, the remainder, what's left over, let's make sure we have r equals, what's left over, our remainder, is simply going to be g of negative 3. Now, why is that negative? Well, because the remainder theorem tells us it's x minus k. So if we're dividing by x plus 3, g of negative 3 gives us our remainder. Okay, so what that does, you might think, okay, great, well, what good is that? Well, what that does, that lets us divide without dividing. We can use something called synthetic division. So if you remember back to synthetic substitution, when we would plug in a number by using that number in the box and dropping down the coefficients and all that, well, that's what we're going to use right here. So we're going to use synthetic division. So let's draw our box. Well, if we want to divide by x minus 2, we're going to put a positive 2 in that box. Okay, drop down our coefficients. We get a 1, a 2, negative 6, negative 9. Draw our line. We drop down the first number, so that gives us a 1. Multiply the 2 times the 1, gives us a 2. Add together, we get a 4. Multiply, we get 8. Add together, we get 2. Multiply, we get 4. Add together, negative 5. So if we divide, we know we're going to have a remainder. This is our remainder right there, that negative 5. But what do these other numbers represent? Well, what these other numbers represent are coefficients of our x terms. This is our constant term. This is our x term. This is our x squared term. So if we divide x cubed plus 2x squared minus 6x minus 9 by x minus 2, what's left is 1x squared plus 4x plus 2 with a remainder of negative 5 over x minus 2. So we subtract 5 over x minus 2. That is our quotient. Where did these numbers come from? Well, they came from our result of our synthetic division. Okay, let's try another one here. Let's say we want to divide this by x plus 3. Well, that means the number in our box is a negative 3. We still have the same coefficients. And we go through the synthetic division. So we drop down the 1, get a negative 3, negative 1, get a positive 3, negative 3, get a positive 9, get a 0. Oh, wait, what does that mean? We have a remainder of 0. That means that x plus 3 is a factor of this polynomial. Okay, our remainder is 0. That goes into it evenly. So we're left with x squared minus x minus 3 and a remainder of 0. And that leads us into our second theorem, which is the factor theorem. If a polynomial f of x has a factor of x minus k, if and only if f of k is 0. So let me say that again. A polynomial f of x has a factor x minus k if and only if f of k is 0. So what that means, x plus 3 was a factor of our polynomial because f of negative 3 was equal to 0. Alright, if we have f of 6 for some function is equal to 9, well, it's not a factor. X minus 6 is not a factor because f of 6 is not equal to 0. So if, that's what the if and only if means. So we have to have f of k equal to 0 for x minus k to be a factor. All right, let's look at how that helps us here. So we want to factor this polynomial given that f of negative 3 is 0. So we know that f of negative 3 is 0. What that tells us is x plus 3 is a factor. Okay, well, if x plus 3 is a factor, let's divide that part out of the polynomial. So let's use synthetic division. Put negative 3 in our box and a 2, drop down the coefficients, 11, 18, 9, and then we drop down the 2, get a negative 6, get a 5, get a negative 15, 3, negative 9, 0. Now, keep in mind, if this is not 0, you did something wrong because we're told that the factor, we should get a 0. Okay, well then you ask, why did we do all this? We already know it's going to be 0. Well, yes, that's true, but this is what we're looking for. These numbers right here. What do those represent? They represent 2x squared plus 5x plus 3. And that's what's left. This is what's left of our polynomial. So we know that if we multiply x plus 3 by this quadratic, we're going to get our f of x. Well, we look at this and say, well, can we factor this even more? And the fact is, yes, we can factor this using what we did in the last chapter with factoring quadratics. We can see that this factors into 2x plus 3 and x plus 1. And we still have the x plus 3 there. So this right here is our factored form of our polynomial. So if we were to distribute all of these, if we were to FOIL and then distribute, we would end up with our f of x at the beginning. And so we're going to continue to use this in factoring polynomials and later on finding zeros of polynomials. So what you need to do for tomorrow in class, you need to be able to divide polynomials by long division and divide polynomials using synthetic division. Synthetic division is a little easier. We're going to use that more often. So you need to know how to divide using synthetic division. So make sure before you come into class tomorrow that you know how to do those two types of division and an idea of how to factor polynomials given a 0. All right, well, we'll talk about some more examples tomorrow. We'll go through these notes quickly and be able to talk through any issues.